Hello friends, in this session we will see armature reaction in synchronous motor. We will see it at GPF lagging, leading as well as at ZPF lagging as well as leading. Let us begin. Now we need to understand one thing here. The moment we talk about synchronous motor, right? Which means what? Definitely the output which is there is going to be mechanical energy, correct? Mechanical power. And we have known that this particular mechanical power which is there, it is always going to be active power, correct? Or we can say real power. Now fact here is we need to understand one thing, that how can we have lagging conditions as well as how can we have leading conditions. Okay, we will try to see that. See, we need to understand one thing. Basically you have a motor, it will be having a stator, correct? And then here we will be having the rotor, correct? That is what we have seen. And it is going to draw electrical input or rather electrical power from the source, correct? Yes. Now whatever it draws, the current it draws, this is going to be armature current, IA current, right? Armature current. Now we need to understand one thing. Whatever it draws, we need to understand how it happens. See here. For example, if whatever flux lines are required, let me tell you that. Wait, see here. For example, flux lines required to operate for normal operation. Basically, we have talked about it in our video, that is synchronous motor as a single phase transformer. Refer that video please, and then you can come here, correct? Now anyway, if you think of example, if flux lines required are, let us say, equal to 100 flux lines, example. Now you have field current, right? We know that when you think of the stator, this is stator, correct? And here we will be having the rotor, correct? We will be having the rotor. On this rotor there will be definitely field windings, correct? Through this there will be IF, which is the field current flowing through it. Is that right? Because of this particular field, it will produce some flux, correct? Yes, 100%. Now this particular flux, for example, if it is exactly equal to 100 flux lines, this particular flux which is produced by the machine or the field, if it is exactly equal to this 100 flux lines, then we can say that this particular motor which is there, it will draw unity power factor currents. See, if you think of, if your field, if it is able to produce 100 flux lines now, which is what is the required flux line, then your motor will draw unity power factor currents, correct? Yes. Now for example, if your required is 100 flux lines only, same, but if your field current, this field which is there, if it is able to produce only 80 flux lines, for example, then we say that the extra flux lines has to be set up, correct? Yes. So in order to set up those extra flux lines, we need to draw lagging currents from the stator. Is that correct? Yes. And the last point is, example, if you are able to produce 120 flux lines, you in the sense field, this particular field current, if it is able to produce, for example, 120 flux lines, then it means that required is 100, correct? Which means already 20 are there which are extra, 20 flux lines are extra. So in order to destroy those extra 20 flux lines, we need to draw leading currents. Correct? This is how we need to understand it in terms of synchronous motor. Again, I am repeating it. If you are not understanding it right now, please watch this particular video which is in our section. It is nothing but synchronous motor as a single phase transformer. Please refer this particular video. Watch this video once or twice, whatever you feel good. Okay. Now let us try to understand the armature reaction into same. Okay. Yes. Let us think of what happens at unity power factor. Correct. Let us see what happens. Let me draw stator and rotor as usual, which we had earlier. Correct. Now, since if you think of your synchronous motor which is there, it is not a self-starting motor. Not a self-starting motor. Correct. That is the reason we need to assume the rotation here. Let me call it as omega. Definitely, I will not be able to show you, what do we say, starting torque of our motor. Why? Because it doesn't occur. Because your synchronous motor does not have starting torque. Correct? That is the reason we will only try to think of steady state running conditions. Running steady state conditions over here. This is our intention right now. Correct? Yes. Anyways, now if you think of this one, that this is my field which is red, right? Red is my field rotor and it is rotating with omega. Correct? Now what will happen here? If you think of in your stator conductors, what is going to happen? In your stator conductors, definitely at A, this particular A will have dot induced voltages and this A dash will have cross induced voltages. Is that correct? Yes. You will understand this by using right hand rule. Right hand rule will tell you that yes, here dot will be produced and here cross will be produced, as in the same as alternator, right? Now this is what, this is nothing but maximum induced voltages. Correct? Maximum induced voltages, that is what is there. Now if you think of the voltage current relationship in case of unity power factor, unity power factor in the sense resistive, so definitely this is going to be like this. So this becomes your current I red and this blue is nothing but your voltage. Okay, so voltage is there. Now if you think of both voltage maximum and this current maximum occur at the same instant. Correct? Yes. Which means what is going to happen now? At the same instant I will be having the current maximums. Current maximum. Correct? Now we need to understand one thing. Whenever we talk about synchronous motor, we have seen that the voltage and the VI characteristic, if you think of voltage and V and I are in opposite direction to each other. We have already seen this, correct? Are in opposite direction to each other. Already we have talked about it earlier. But still, if you are interested into it, let me just give you one simple example. Do you agree that your synchronous motor which is there, it is a load, correct? Motor, but yes, definitely it is a load, correct? Now, which means it is going to absorb electrical power, correct? So by using passive sign convention, by using what? Passive sign convention, we have seen what is going to happen. What is going to happen if this is the voltage across it, then this is how the current flows. Means it should be entering into the positive of the voltage. Is that correct? Yes, which means if you think of induced EMF and this current I are in opposite direction to each other, are in opposite direction to each other. By the same logic, if you think of here, now what will happen? Definitely here we had dot, so here I will be having cross, and similarly here I will be having now dot. Now if you think of for this particular current maximums, if you think of why, because see, we know that definitely everywhere, definitely in B dash also it will be there, C also it will be, C dash also, B also, everywhere it will flow, but maximum currents will flow in this A conductor and A dash conductor only. Is that correct? Now we have seen that three time displaced currents flowing through three space displaced windings will have one rotating magnetic field which will align in the axis of in the axis of mmf in which maximum current flow. Is that correct? That is the reason for us maximum current is important. Same logic whatever we have seen for alternator. Is that correct? Yes. Now if you check out here, what is going to happen? Let us see. Now by using again right hand rule, you will get that your FAR, your mmf because of this is going to be your mmf because of this is going to be like this. This is your FAR, correct? Yes. Now you know that this is the direction of your FF because this is north pole, so definitely this is going to be FF. Now if you add them, what do you get? If you add these two, what do you get? If you add this FF and this FAR, you get resultant, which resultant comes here, so this becomes your FR, correct? Yes. If you think of in the stator side, it is entering the stator, which means definitely here I am going to have south pole of the resultant, and here on the opposite side I will be having north pole of the resultant. Is that correct? Now this north of the field and this south pole of the resultant will get attracted to each other, which means there will be torque, which means there will be torque in this direction. Now if you think of this, torque and speed are in the same direction. Torque and speed are in same direction. Is that correct? Yes. And this has to be there because it is the important property of a motor. Is that correct? Yes. Now we will try to see what happens in case of a lagging condition. Let us see what happens. Case 2 lagging. Now when we say it is lagging condition, which means your V and I will look like this. This is a voltage, for example. If this is a voltage, this is your current I, which is lagging this one, correct? Now if you think of between voltage maximum and this is going to be current maximum, is that right? So definitely this is going to be theta, which means what? After some time, means if you are standing here at V max, then after some time I max will occur. Is that correct? After some time I max will occur, correct? So if you think of now what happens by using right hand rule, you get that here I will get dot and here I will get cross currents, cross induced voltages. I'm so sorry, it is induced voltages, so these are going to be maximum induced voltages, correct? Yes. Now where will be my Imax? We need to understand. Let us see what will happen since it is lagging by some angle theta, which means definitely it will be somewhere here, correct? So this becomes your cross and this because it is going to lag behind it. So if you think of if this is dot, then this has to be definitely cross, correct? Why? Because we have seen that voltage and the currents are in against to each other, correct? Yes. So what is this then? This is going to be maximum currents. Is that right? Now again by applying the same right hand rule, what do you get then? You get that you will have one rotating magnetic field which will be produced and it will be along the axis of mmf in which maximum currents flow. Is that right? Yes. So if you think of FAR will be somewhere over here. If you think of FAR will be somewhere over here in this case, becomes your FAR, mmf of the armature, correct? Now the field mmf is definitely here. Is that right? FF. This is going to be your FF. Now if you think of the resultant, if you think of the resultant, this comes here, this comes here. So if you think of resultant, here is what resultant comes. This becomes the resultant, which is FR, correct? Yes. Very simple. Now if you think of since it is entering into stator here, this becomes south pole of the resultant and this becomes north pole of the resultant, correct? Exactly diametrically opposite to each other. Now what do we have next? See, this north pole and the south pole of the resultant will get attracted to each other or not? Yes, they will get attracted to each other, which means what is going to happen now? There will be torque produced in the same direction. Now if you see torque and omega are both in the anti-clockwise direction, this is what we need. Now if you think of your armature reaction, what is the armature reaction? With respect to FF, if you see your FR has increased, which means it is going to be magnetizing armature reaction, Is that correct? Yes. And if you think of speed and torque, they are in the same direction. We have seen that. Now we will try to see Leading conditions. At leading, let us see what happens at leading. Now, what do you mean by leading? Leading in the sense, if this blue is your voltage, then if you think of current I, then it will start here somewhere. It will go here this way and this way. This is what is your current I, which will be leading your voltage, correct? Yes. Now, if you think of, if this is current maximum, this is voltage maximum. Now, if you think of, you are standing here at voltage maximum, you understand that current maximum has already gone before, correct? Same things as of alternator we have seen, correct? Now, let us think of our stator and rotor. Again, if you see, it is rotating in the anti-clockwise direction omega, correct? In this conductor A, you will have maximum induced voltages. Here you will have dot and here you will have cross. So these are what? Maximum voltages, correct? Maximum voltages. Now, where will be your I max? Where will be your I max? If you see, it is going to be leading to my pole. So definitely somewhere around here, I will be having I max. So here at this position, I will be having my I max. So here if I have dot, then here definitely I will have cross and here definitely I will have dot, correct? Yes. So this is nothing but your maximum current maximum, correct? Now, if you think of again, same old story, 3 time displaced currents flowing through 3 space displaced windings will produce one rotating mmf, which will be what? Which will be definitely aligning with the axis of mmf in which maximum currents flow, correct? That is the reason maximum currents are important. We have seen that. So if you think of your FAR, where does that look then? Where is your FAR then? If you think of this as dot and cross, then you get your FAR to be somewhere over here. Now, if you think of FF, then this is your FF, field MMF, FF, correct? Yes. Now, if you think of resultant, where do you get the resultant then? Resultant will be somewhere like this. This is your FR, which is what? Resultant. Is that correct? Yes. Now, again, if you see your FR, which is there, it is less than this FS, so definitely it is going to be demagnetizing armature reaction effects. Yes. And another thing is, if you see here, since it is entering here in stator, so this becomes south pole of the resultant and this becomes north pole of the resultant, correct? Now, this north of the field and the south of this resultant which is there, they will get attracted to each other. So you will definitely have a torque in this direction, which means now again, if you observe, this torque and this speed are again in the same direction, which is the important necessary property for a motor, correct? Now, let us think of ZPF lead. Why? Because we need to understand something called as synchronous condenser. What is synchronous condenser? We will try to understand here itself. Okay. Now, add ZPF lead. Let us see what happens. Now, what do you mean by ZPF lead? It is going to be zero power factor. So definitely, VI characteristics will be your voltage, which is there. Your voltage is going to be this way, correct? And this is going to be your current I. So it is going to be like this. Current I is going to be like this. So if you think of current maximum is here, voltage maximum is here. So, and the angle between them is going to be 90 degrees now, exactly 90 degrees, correct? We will try to see how it happens now, correct? Now, let us bring this to our stator and rotor concept, correct? This is your stator, correct? Now, inside this I will have a rotor, correct? Yes. And it is rotating, let us say, with the speed of omega now. It is synchronous motor, correct? Running conditions. Now, again, by using right hand rule, what do you get? You get that here you will have dot and here you will have cross. So this is going to be maximum induced voltages. Maximum voltages, let me write down, correct? Now, what is happening? If you see, if you stand here at voltage maximum, you understand that current maximum has been already gone. Current maximum has been already gone 90 degrees before, which means definitely current maximum is going to be here. Now we want it in opposite direction, so if this is dot, then definitely this has to be cross and this has to be dot. Correct? Now if you think of the MMF because of this armature, this MMF because of this armature is going to be, by using the same right hand thumb rule, you get that this is going to be this way, which is going to be FAR. Correct? Yes. Now if you think of FF, where is going to be FF? FF is going to be in the same direction. This is FF. Now you see FF and this FR, they are in opposite direction or not? Yes. Which means your resultant FR is going to be somewhere here. This becomes a resultant FR, right? Yes. So because of this resultant FR, definitely if it is entering here, so this becomes south pole of the resultant and this becomes north pole of the resultant. Correct? Yes. Now if you think of what has happened, magnitude of FR is less than magnitude of FF, which means definitely it is a demagnetizing armature reaction, if it's correct. Now demagnetizing armature reaction, it means machine is going to be what? Overexcited machine. It is going to be overexcited machine, and we have seen earlier that overexcited synchronous machine supplies reactive power. Is that correct? Supplies reactive power. So whenever you need reactive power, you can use this as your motor. Now if you think of, you can use, because it is overexcited machine, not just overexcited motor. It means what? See, when we think of overexcited synchronous machine, we always consider both generator as well as motor, correct? Yes, but if you think of why we are only using motor in order to supply reactive power, rather we only use motor as synchronous, remember this name, synchronous condenser. Why do we use it? Let us understand. Why do we not use generator? Because when generator can also supply reactive power, motor can also supply reactive power, still we are using motor only as a synchronous condenser. Why? Let us try to understand that. It is a very simple reason. If you see, whenever we use our, whether it is generator or it is motor, correct, whenever we use them at ZPF lead or at ZPF lag, we know that there is no torque. Torque is going to be zero, correct? Even here, if you see this south pole of the resultant and this particular N pole, they are what? Exactly in front of each other, which means torque is going to be definitely zero here, correct? We all agree with that, sir, no problem, right? So, but then you may say that, sir, yes, but if torque is zero, then it is zero in case of generator as well as in case of motor. Is that correct? Yes. But still, why we are preferring synchronous motor is because see dear, when we think of synchronous generator, you will have to first rotate it or not. Yes, rotate it. And in order to rotate it, you need to use something called as prime mover. Correct? We need to use something called as prime mover. The moment you use prime mover, which means definitely you need different machine in order to rotate it, right? Whereas if you think of motor, you do not need extra machine, or we can say not need separate machine. This is the reason why we use the synchronous motor only as a synchronous condenser. Getting my point? And now if you think of shaft, what will happen? Another thing is diameter of the shaft will be less. Why? Because if you see, when we say the torque is zero, which means back torque is zero. Basically, torque zero means back torque is zero. Correct? Which means what? Active power will not be supplied. So if you think of motor, shaft of motor, if you see, basically it is used, or we can say shaft of this motor is used to what do we say, load our mechanical loads, correct? Like for example, brake drum and all, correct? Yes. But now since active, what do we say, since you are only supplying reactive power, since you are only supplying reactive power, which means you are not supplying any active power, correct? Which means there is no need to have a great shaft, which means again it will become cheaper, because we have seen that earlier that shaft is the only instrument in rotating machines which is the most expensive instrument, correct? Yes. Then next thing is again same old story, because you don't need any active utilization of this motor, shaft will not be brought out, shaft will not be brought out. These are the reasons, why we do not prefer generator as a synchronous condenser. Rather, we only prefer motor to be as a synchronous condenser. These are the reasons. Simple old story. We do not need separate machine for this. Number one. Number two is what? Since we don't need any great shaft, so it becomes cheaper. Second point. And the third point is shaft will not be brought out. Why? Because you are not at all utilizing any active power. Is that correct? Yes. Now let us think of ZPF lag. What do you mean by ZPF lag? Basically, your voltage and current relationship. This is voltage, correct? So this is voltage. Then here comes your current. Start exactly after 90 degrees. So this becomes your current. And the angle between voltage maximum and the current maximum is going to be exactly 90 degrees, correct? Yes. So if you stand here at the voltage maximum, then you understand that you will have to wait for some time in order to get current maximum. Is that right? Yes. We have seen that. Same old story for alternator which we had seen earlier, correct? Now, let us try to see it with respect to our stator and rotor, correct? Now, if you think of stator, this is going to be a field which is rotor and it is rotating at speed of omega, correct? Now, again, by right hand rule rather, you get that this is going to be dot induced EMF and this is going to be cross induced EMF. So these are nothing but what? Maximum induced voltages, correct? Yes. Now next, when will you have current maximums? Let us see. You will have to wait for 90 degrees in order to have maximum currents, which means maximum currents will be here and here, correct? Yes. If this is dot, then definitely this has to be cross and this has to be dot, correct? Yes, because they are in opposite direction. Now next, what do we understand is by using right hand thumb rule, what do you get? You get that you will have MMF in this direction, which is FAR, correct? Yes. Now your FF is here. Now if you add this FF and FAR, what do you get? If you add FF and FAR, you get one resultant which is FR. Now if you see FR magnitude is more than FF magnitude, which means definitely it is going to be magnetizing armature reaction effects. Is that right? Now the best part is what? Best thing is what? Yes, we know that in case of synchronous machines, whether it is generator or a motor, doesn't matter to us, correct? We have seen that what is going to happen, there, your time and space are synchronized, correct? Time and space are synchronized. That is the reason we can also place or we can also combine time phasors, time displaced phasors also in our space displaced phasors of mmfs, correct? Which means definitely I can show your induced emf ef, we can also show er, and we can also show ia. So let us try to show them on each and every graph. So this becomes your ia, correct? in line with FAR, armature MMF, correct? Now, next will be your EF. EF will be what? With respect to this FF, it will be 90 degrees here. This is going to be your EF. Where is your ER? Definitely, with respect to this FR, this ER is going to be here. This is going to be your ER. Similarly, if you think of here, where will be your IA? IA will be here, in line with FR. If this is your FF, then this is going to be your EF, correct? If this is your FR, then definitely 90 degrees from this is going to be your, what do we say, ER, correct? And if you see again, mod of ER is going to be greater than mod of EF, correct? Now, if you understand, simple thing, see, what we can show that this is going to be your FF, then this is going to be your EF because of this FF, then you have this IA which is lagging, then you have this phi AR which means you have, let us say, MMF FAR, then if you add them you get one resultant which is going to be FR, correct? One the resultant you get which is going to be FR, and with respect to this FR again, here you will be having by 90 degrees, here you will be having ER. Simple old story, correct? Which means basically from now, if you see, we will be only using phasor diagrams which we had seen in our single phase transformer case. Single phase transformer, in the sense, if you see, we had seen made one separate session for, what do you say, alternator as single phase transformer. We had done a separate session on alternator as single phase transformer, and we had done a session on synchronous motor as single phase transformer. From there, whatever we had understood, whatever phasor diagrams we had got, the same phasor diagrams we will be using in case of problem solving, correct? Rest, no need to do anything. Rest, this is just okay. This was for your understanding purpose. Now we have understood armature reaction in a proper sense. After this, we will see some observations out of this and then conclude the whole session. Thank you.